Hello friends, today we're going to be looking at more geometry, more ways of telling that triangles are congruent. So we've already seen from lesson 25, the side-side-side triangle congruent postulate. And then in lesson 28, we saw the side angle side triangle congruence postulate. Today we're going to look at another one. So this is called the angle side angle triangle congruence postulate. I just wrote postulate for short, but here's the idea. If we've got two angles that we know are congruent, and then the included side between those angles. So we've got two triangles and the corresponding parts, right? Angle, angle, and then the corresponding included side. Then we know that those two triangles as a whole are congruent. So here's an example diagram. Triangle or angle G and angle L. These angles are congruent, and angle A and angle S. Those angles are congruent. And now look at the side. It's the included side between the two angles. You could say that this side is a side of both angles. So if we have that type of situation, then we know that these two triangles are congruent. Don't forget, when you're writing triangle congruence statements, the order matters. You want the corresponding parts to match up with one another. You can think of it this way. We know that the three angles inside a triangle add up to 180 degrees. And so, if these two angles are congruent, then we know that this third angle has to be congruent also. Okay, so we know that these two triangles are what we call proportionate, right? If the angles are all the same, then they're proportionate. And then, the question is just the size, right? They are the exact same shape. Now the question is the size. But even if just one of the sides are congruent, then we know that the rest of the sides have to be congruent with one another. Okay, and so this is the angle side angle congruence postulate. Then directly from this, we can also get the angle side theorem, right? So if two triangles are congruent, and this one's a theorem because this one you can prove, and that might be part of an exercise somewhere actually going through the proof. But it's based on the same kind of reasoning. If we have two angles that are congruent to two other angles, and a non-included side is congruent to the corresponding side of another triangle, then we know that those two triangles are congruent. So again, same diagram, except I just changed the signs to what's congruent to what. So again, these angles are congruent. This angle is congruent to this angle, right? Angle M, angle D. Look at this side now, side CD and side MT. These sides are not included between the two angles. So that's the not included side. So it's kind of like if you're going around the triangle, you go angle, angle, side. You have to go through both angles before you get to the side. Right. Over here, if you start at one angle, then you're going angle, side, angle. You have to go through the side before you get to the other angle. And so here are a couple of examples. If you look at something like this, do we know that these two triangles are congruent? And the answer is yes, we do. Even though we've only got two angles that are marked, you can see, this angle is congruent to this angle, and this angle is congruent to this angle, but they share a side. When you're dealing with problems, proofs, questions, you've got to start to use all of your resources that are available. This one is a little too easy to miss, right? It's hidden in plain sight. This is a shared side. So this side is obviously congruent with itself. You would call that the reflexive property. If you were putting it in a proof and you wanted to say segment LG is congruent to segment LG, you would write that as the reflexive property of congruence. Remember, reflexive is like you're looking in the mirror. It's the same thing that you see on the other side. And so here you could prove that these two triangles are congruent using the angle side angle congruence theorem. Same idea now, just a different arrangement of angles. Let's say we don't know for some reason these angles, this angle and this angle are congruent, but now we know these opposite angles are congruent to each other. So now, is this triangle congruent to this triangle? The answer is still yes, because again, there's a shared side. Always look for like shared sides, parallel lines. So you've got the different angle relationships, vertical angles, right? When you got two lines that cross, the vertical angles are congruent. Those are all different things that you can use. In this case, we're using, again, that shared side reflexive property. And so this is going to be this would be an angle side congruence. This one's a theorem, we say. The other one would be the angle side angle congruence postulate. And different textbooks, by the way, are going to name these differently, either as theorems or postulates, depending on how they take the time to go through and prove each one of them or just assume them to be true. So if there's a different textbook that you're using and it's like, hey, it's a theorem in this one and it's a postulate in that one, and they go in a different order, that's okay. Each textbook and each teacher has its own way of doing things. So in this case, I'm just following the Saxon text. So as you can tell, a lot of work with triangles. They're foundational. We're going to continue to learn about triangles. That's not stopping anytime soon. So thanks for watching. Don't forget to like and subscribe and share.